Hi guys, in this video we're going to start looking at the fundamental laws of electricity or circuits, and here we have one question coming from an assignment. Let's see how you were supposed to answer this. So this is just basic concepts, so let's see how you approach them. In the first part they're saying calculate, so they're saying we calculate the current I in the figure. So where's I is the current coming from the source there. Calculate the current I in the figure below when the switch is in position 1. Position 1 is when the switch is connected in that orientation. So when the switch is connected like that. So how do you do that? So in that orientation, what happens? Notice that then this line here is now incomplete. So this line will be not in use. So it's as if that line is not there. So you might as well look at this line as if it was not there altogether. So you can shade it out. So when the switch is in that position, this line behaves as if it is not there. Of course, you don't want to try touching it. That's something else altogether. So the circuit will remain just like this. So then in terms of current, we see that this is a basic circuit where you have a source, a 40-volt source supplying current to the 100 ohm resistor. So by Ohm's law, you have V is equals to IR. So seeing that we only have one resistor, no need to combine. That is the whole resistor in the circuit. So you have 40 is equals to I multiplying that 100. So that now we have I is equals to 40 over the 100. And when we divide, we have 0.4 amps. So this becomes the current in our line. Okay, but now let's look at in the second part, find the current when the switch is in position 2. So position 2, we're going to bring back this side, and now we're saying the switch is now connected to this point here. So if the switch is in that orientation, what changes? So for this part, we see that it's like this line here will now be the one that is offline, because now it will be incomplete. The switch is connected that side. So again, this is all that remains. So for this case, what would now be the current leaving that power source? So again, polarity is still okay. We're still leaving the positive end of the battery, which is good. But now by Ohm's law, we see that we only have one resistor, that 250 ohm resistor in our line. So you have V is equals to IR again, Ohm's law. The voltage, we have, let's do it down here. So you have V is equals to IR. The voltage is still a 40-volt supply. The current is what we're looking for. The resistor this time is the 250 ohm resistor. So this is multiplying 250 ohms. So when you do the math here, we get I is equals to 40 divided by 250. The zeros fall off. We now have 4 divided by 25. And this gives us 0.16 amps. So this will be the current in the line when that is our connection.